Hi everyone. Today we're going to talk about parabola in terms of its geometric analysis. You've talked about parabolas before in terms of algebraic functions, so today we're going to do something a little bit different. Um, if you notice, the definition of a parabola that I have up here is very different than the function that we describe in terms of a quadratic equation. So it's all the points on a plane that are equal distance from a fixed line, which we call the directrix, and a fixed point, which we call the focus. The focus does not lie on the directrix. Now, you might hear this and just hear a lot of blah, 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 blah. So let's do this. I'm going to draw a picture. And from this picture, we're actually going to generate the equation for a parabola. And what I'm going to do is I'm going to let my parabola have a vertex at the origin. Just to start it out this way, it makes it simpler. So it looks something like this. Okay, there's a parabola. Now it doesn't have to be oriented like this. This is a parabola in terms of a function, but this is also a parabola in terms of our definition here. So we'll start with our vertical axis of symmetry, just because that's what we're most familiar with, and then we'll turn it on its side in a minute. So it's all the points on a plane who are equal distant from a directrix. Let's put the directrix down here. The directrix is always going to be perpendicular to your axis of symmetry, so we'll call this the directrix. And the focus, which actually always lies on the axis of symmetry, put that right there, we'll call this the focus. And we'll call this the directrix. So it's all the points on the plane that have the same distance from the focus as they do from the directrix. Now, of course, mine isn't perfectly to scale, so it might not look exactly perfect, but you get the idea. So let's take a point anywhere on this curve, okay? And I'm going to take the distance from that point to the focus and that point to the directrix, okay? So let me put the value here for the focus is on the y-axis to be 0p, okay? And we'll call this point F for focus, okay? And then I'm going to also put a point directly down from this coordinate, let's call this xy to keep it very general. If I drop directly down from that down to my directrix, I get this point. It's still going to be same x value. Now here's the thing with the y value. You say, well, what is that coordinate going to be? Well, if it's all the points on the plane that are the same distance from the focus as they are from the directrix, and here we've got the point 0, 0. Okay? So if the focus is some value p away from that vertex, then you know what? The directrix is also going to be some value p away from that vertex. So that gives us this equation, this horizontal line here, this directrix, to be y equals negative p. Which gives us the coordinate down here, because watch, if we drop this straight down, we say we're going to use that same x value going straight down, the y value is actually going to be negative p, because we're on that horizontal line. Okay? And we'll call this point D for directrix. And let's just call this point here, let's call it Q, just to give it some arbitrary name. Alright, so what this definition is saying, it's saying that the distance from F to Q, from the focus to this point, has to equal the distance from Q to P. I'm sorry, Q to D. That's what that definition says. It says all the points on the plane that have the same distance from the focus as it does from the directrix. So there's the equation. That's the same exact statement as the definition above. Now from this, we can use our distance formula, and we can actually come up with the equation of a directrix that has a vertical axis of symmetry that has a vertex at the origin, just by applying this statement here. So what I'm going to do is I'm going to use the distance formula and find the distance from F to Q. So the distance from F to Q, by my distance formula, it says x sub 2 minus x sub 1, so it's going to be x minus 0 squared plus y sub 2 minus y sub 1. So y minus p squared. There's my distance f to q. And I can simplify this a little bit. I get the square root of x squared plus y squared minus 2py plus p squared. Just foiling that out, that's where I'm getting that little piece there. Okay. Now my distance from q to p is going to be the square root of x sub 2 squared minus x sub 1 squared, so x minus x squared plus y sub 2 squared minus y sub 1 squared. So it's going to be y minus a negative p, so I get y plus p squared. Okay. Now when I expand this piece out, I'm going to get those x squareds are going to the x's are going to cancel. I'm going to get y squared plus 2py plus p squared. All right. Almost done. What I'm going to do by this statement, I have to set these two pieces equal to each other. It looks a little bit messy, but it's going to collapse down to something really nice. So we're going to take the square root of x squared plus y squared minus 2py plus p squared. This is my distance from f to q. I'm going to set it equal to y squared plus 2py plus p squared. That's my distance from q to p. Okay? I have a square root equal to a square root, so I can square both sides to get rid of that, and I'm left with x squared plus y squared minus 2py plus p squared equals y squared plus 2py plus p squared. Now what I'm going to do is I'm going to actually solve for x squared. So I'm going to move everything over to the other side. And the way I'm going to do that is just, simple algebra. I'm going to subtract my y squared and add my 2py and subtract my p squared. And do that same thing to the other side. And this is what we get. X squared equals 4py. Notice the y squares are going to cancel, the p squares are going to cancel, and this is what I'm left with. This is the equation of a parabola with a vertical axis of symmetry and the vertex at the origin. P is the distance my focus is from my vertex, and the distance my directrix is from my vertex. So my directrix is going to be y equals negative p. Just really do that. Y equals negative p, and my focus is going to be at the point 0p. Now, if my p were negative, the effect that would have on my graph is the graph would flip upside down. It would be pointing down like that, which gives me my directrix to be above the x-axis at a positive p-value. One way I always remember these equations is I say if I have an x squared, I'm going to mess with my y's. So that means if I have x squared, it's going to be a y equals directrix. If I had y squared, it'd be an x equal directrix, which we'll cover for the next session. So this is how we derived that equation. If you watch the next segment on this, I'll actually do a problem with a similar situation.